thank you, Shord. I'm saying your name right. Am I correct? Okay, that's an accomplishment already. And Peter Verberg for inviting me here, and also, of course, the Environmental Humanities Center. It's great to get a chance to speak here in Netherlands, as I think you all know, right? God made the earth, but the Dutch made the Netherlands. And that has a lot to do with the Anthropocene. We're right now making the planet that we're living on. So I'm going to divide my talk into 4 basic areas. And the first will be the area that you hear a lot about when people are talking about the Anthropocene. And I'm going to just assume that all of you have heard this term before, and I'll describe it in some different ways. But it's basically this concept that we have a new period of Earth's history in which humans are the primary transformer of Earth's systems. So we'll start with a question that is often asked, and that I've worked with the Anthropocene Working Group. When did the Anthropocene begin? And then I'll move relatively quickly to a more interesting question. Why did the Anthropocene begin? The whole question of when, I think, is in some ways something we can look back on and deal with in the future. But why we're doing this, why are humans transforming the Earth, is a question that has great consequences for what we're going to do right now. And then I'll talk about the shape, at least of ecology, that humans are creating through the anthropogenic activities that we're doing. And I'll talk about a theory about why we're doing this. And finally, I'll end with a look at what the possibilities are. A lot of people think about the Anthropocene as kind of the end of the world, but I think it's more important to think about it as the beginning of a new period in which we consciously do something to the Earth instead of just letting it unfold unconsciously. So I always show this slide, even though you're probably bored to death of this picture. You've seen it many, many times, right? This is the Earth at night, and these are nighttime lights taken from a satellite. And the reason that I continue to show this, and I'm an ecologist, so I'm very often talking to natural scientists, not so much social scientists. And from a natural scientific view, there's often this idea that we can understand the Earth, we can understand life without the sociality that we have. And in reality, there's no way that we can understand this pattern, the fact that the Earth now glows at night. It never did before. This is completely a human thing. There's no biological explanation for this. There's no physical explanation for the fact the Earth now glows at night. This is a social process. It's all of these people interacting over generations and generations, building a physical, material infrastructure that has accidentally caused the Earth to glow at night. Nobody wants the Earth to glow at night, yet the Earth is glowing at night. That is a great metaphor for the Anthropocene. It happened while we were busy making other plans. And I'll also look at it through these other ideas. Everyone, I think, talks about current environmental change as a crisis, and there's good reasons for that. Obviously, we're doing things to the planet, like heating it up at unprecedented rates, and that's a very risky, dangerous business. And it has led to looking at the very recent effects of what humans have done. And this concept of the great acceleration, if you're not familiar with it, is the fact that if you look at a large array of human indicators of Earth transformation, you can see all these different ones here, population growth and water use. Just about everything about the way humans are changing the Earth accelerated dramatically after 1950. And for a lot of people, including the Anthropocene Working Group, the International Commission of Stratigraphy, that is currently in the process of actually creating a formal geologic definition of the Anthropocene, this is the indicator around circa 1950. This is the indicator that the beginning of the Anthropocene can be marked with. And what it really leads to is essentially something like this, that the premier marker of what humans are doing to the Earth is something like this, the nuclear explosion. This is the first nuclear test. Okay, and I think if you're somebody who studies what humans actually do to the Earth, I think it's a very disappointing message for multiple reasons, but one of them is just that it does not say anything about what we're doing to the Earth. I think a deeper understanding, and the Anthropocene comes out of looking at the Industrial Revolution and essentially industrial processes. That was Paul Crutzen's original definition of the Anthropocene, is sometime around 200 years ago. And of course, you do have a lot of things that start to change dramatically. And the most obvious one is you start to see very large emissions of carbon dioxide from fossil fuels. And so that's another deeper definition of kind of this Anthropocene crisis. Although, is it a crisis if it lasts for 200, 300 years? Is that still a crisis? Or is it just a process? Is it just something that we're doing? It's hard to think of a crisis lasting for 200 or 300 years. That's before your grandparents were born. Another element of environmental crisis that we often talk about is massive deforestation. And that is a great challenge, and it is something that threatens biodiversity and has large-scale climate effects. It's another way of looking at what the Anthropocene is about. And I think for most of you, if not all of you, you're familiar with the fact that, well, burning fossil fuels releases carbon dioxide to the atmosphere, and that causes climate change. But of course, clearing land for agriculture, tilling soils, burning off forests, that also releases carbon to the atmosphere. It's both things. If you're looking at human transformation of the atmosphere with carbon dioxide and its effects on climate, you have to consider both human transformation of land through agriculture, and you also have to think about these more contemporary forms of burning fossil fuels. And that gets you back a little further in time. Is there anything new about deforestation? In fact, deforestation is incredibly ancient. You could say it goes back before the Holocene, this last period since the last ice age. And this is just a good metaphor for that. What this is a geoglyph that's been exposed through deforestation in Amazonia. And this is not agricultural land use. This is not a building footprint. This is a symbolic structure produced for relatively unknown reasons by some earlier indigenous group about 700 years ago before Columbus. And through this process of looking deeper at these Earth system processes like deforestation, you can see that there's something underneath. There's people doing things before this modern period of deforestation. So we have to think also about the archaeology of the Anthropocene. I think all of you know that the Earth is very dynamic and the climate system is dynamic. And this is just the last 600, 700,000 years of greenhouse gases and temperature changes. It goes back even further, goes back millions of years. This kind of sequence of glacial, interglacial cycles. So what I'm going to talk about now is a hypothesis that is still, I would say, pretty controversial, although it's also growing in, it's basically, nobody's been able to disprove it at this point, that actually there's something unusual about the current geologic time period, the current epoch. If you look here, you're seeing a very confusing mess, right? You're seeing all these traces of greenhouse gases. This one is methane, in which you see all these dramatic curves. And what's interesting here, the general trend you're going to see in all these is essentially the greenhouse gases going up at the beginning of the warming period of an interglacial. This is many of those cycles. At the beginning of an interglacial, you usually see some increase, and then it decreases. The greenhouse gases decrease, and the Earth cools as the greenhouse gases decrease, and then you're going to get another ice age. What's interesting about the Holocene was that red track, is that the Holocene has a very unusual, for both carbon dioxide and methane, it has an unusual pattern. Instead of methane and carbon dioxide just going down over time, it comes back up around the middle of the Holocene. About 6,000, 7,000 years ago, you're seeing this new trend. And what that has been called is, and this anomalous, this trend, has been explained by Bill Ruderman as he calls it the early anthropogenic hypothesis. A lot of people now call it the early Anthropocene hypothesis, in which he blames agriculture, the clearing of land, thousands of years ago for this reversal of this greenhouse gas trend. Now with carbon dioxide, I would say it's relatively controversial still, but for methane, the effects of farming, clearing land and farming, in this case rice farming for methane, is actually not so controversial. But again, I don't expect you to think this is the truth. Nevertheless, it's still an important way of thinking about human transformation of climate, and it's actually quite possibly true. So here are the greenhouse gas trends since the middle of the Holocene, or a little bit before. And you can see this increasing trend. And then here you see the population trend of the Earth. And a very simple question that people have been asking, and it's a very good question. How could so few people, you can see there's just millions of people, just a few millions of people back then. How could so few people change Earth's atmosphere so much? And then the other effect, of course, is when the human population start to really go up more than 1,000 years ago, why doesn't the greenhouse gas just keep going up? Why doesn't it follow the same trend? These are different trends. So those are kind of hard questions about understanding early human effects on the climate system. Now, we're going to get into the answers to that, like how can you explain that with so few people? We're going to get into that in a little bit. Just hold that thought. But the key idea that we're going to talk about right now is all the different things that people have been doing to Earth to transform it since long before the industrial age. And we just talked about atmospheric methane and atmospheric carbon dioxide and its effects on climate. You have all sorts of effects. You have the loss of forests, you have soil erosion. Agriculture is a very novel ecological pattern, obviously, right? You have domesticated organisms, you have the tillage of soils, you have intense populations grazing. And these are all relatively, or these are thousands of years ago, you have these very significant ecological changes. And even before the Holocene, you have in the Pleistocene, the late Pleistocene, you have human-induced extinctions of the large carnivores and large herbivores on many of the continents. As humans moved out of Africa and drove many of these species extinct by a combination of hunting pressures and by changing the environments through burning off the landscape and this sort of thing. This is considered probably the first globally significant effect that humans had on the Earth system. Now, whether this is enough to say, okay, the Anthropocene begins then, I think most people disagree with that. They think this is too minor for an effect. But let's not forget that this was a very huge effect on the ecology of whole continents. When you lose mega herbivores and mega carnivores, what you see is very big shifts in vegetation that occur as a result of differences in grazing pressures and this sort of thing. And that has huge effects on the ecology of entire continental areas, and it did. For example, the mammoth steppe, a whole different type of biome, just disappeared when the mammoth went extinct. The bottom line is, we can't just think of the biosphere, of life on Earth, as this kind of simple natural pattern. If we're doing that, we're going to miss out on the biggest global changes that humans have had so far. So when you teach biology, you're getting this kind of thing. You're getting this in kindergarten, the idea that the ecology of the Earth is shaped by climate into these global patterns. They're called the biomes, but you can call them different things, potential vegetation. And you see in different parts of the Earth, there's different biology, and it's purely explained by natural processes. But that is not going to work in the current time, and it didn't even work thousands of years ago. Humans have reshaped Earth's ecology, especially on land, through agriculture. And cropland and pastures together occupy about 40% of Earth's land. So this is a very significant effect, and it's even more significant because it's not all done in one place. There's not croplands on one part of the Earth and rangelands in another. They're often very mixed together. And to understand this as a global pattern, a global process by which humans are transforming ecology, we came up with this idea of anthropogenic biomes, shaped by human activities from agriculture and settlements, building infrastructure. This creates new patterns of ecology. And we shouldn't just think in terms of natural Earth ecology. We have to think about the ecology that we've shaped. And this covers about 3/4 of Earth's land. Now, this was as far as I got before the next part that I'm going to talk about. The big question is, so you've got this big pattern. We've got this idea of the Anthropocene. This one single species in the history of the planet is transforming the Earth. No other species has done that. People often bring up the example of cyanobacteria, the blue-green algae that first put oxygen into the atmosphere. That was many species, and that was tens to hundreds of millions of years. Okay, humans have done this in a short time, a single species. Why? What is unusual about people that makes this possible? The first law of the Anthropocene, I would say, is that humans are this transformative force. It's a kind of obvious thing, but we often don't realize how unusual it is that a species does what we have done. And so what I'm going to talk about now is why. Why have humans gained this unprecedented capacity to transform Earth? I'm going to look at it from the point of view of the big picture. So obviously, humans are transforming the Earth in many different ways. And if we look from year to year, we want to understand, why are people building new buildings around here? I would call that the human weather. Why is agriculture appearing in Indonesia right now to grow palm oil? This is the short-term dynamics. Just like the weather, it's somewhat hard to predict, it's always changing. Yet there's still this bigger picture, this very long-term changes, the very global changes. This is the climate, the human climate. That's what I'm going to talk about now, the very long-term changes, the very broad changes in human societies that have made it possible to transform the Earth. So this concept of anthroecology theory is this idea that we can explain this unprecedented phenomena of gaining this very large-scale transformative capacity through this evolutionary process called sociocultural niche construction. And that's probably the worst word that you're going to have to get from this thing. Hopefully I can explain it properly. If it's very difficult, the paper is there. It's a long paper. There's some videos, whatever. Hopefully I can do justice to it here. But it's this basic idea that through human niche construction, conducted as a social process, we have a transformative force on the Earth. So let me explain what that means. And we'll start with the basics. So I would call this kind of your obsolete, old school view of evolution and biology and basically how environments work. So when you think simply about evolutionary processes, everyone knows that species have to adapt to their environment, right? They're shaped. It's a one-way street. The abiotic is the kind of the non-organic environment, and it's forcing, say, the climate, the soils, and all that. Species have to adapt to that. So it's kind of a one-way street. Climate forces the species to adapt. Okay, and so that's the classic view, and you just have genetic inheritance. The species gain adaptive genetic traits through natural selection that's caused by the forces of the environment. But there's a new theory. It's not that new. It's just around, I'd say, 15 to 20 years old, called niche construction. And this is an evolutionary theory in which it deals with the fact that a lot of organisms, and humans are the classic example, but it's possible to say that almost every organism has some level of this capacity. Organisms alter their environments. They don't just passively deal with the environmental alterations that are put on them from external forces, but they actually change the environment. So the classic example that we like, because it does something similar to us, it builds a dam. The beaver is the classic idea of ecosystem engineering. So that alteration of the environment, not just through feeding and this sort of thing, but actual behaviors that alter the environment, is called ecosystem engineering. And when this alteration of the environment produces a selective advantage, an organism that does this can reproduce better. That's called niche construction, because that added adaptive capacity gives this kind of ecological inheritance. This capacity to reproduce better is actually an inheritable capacity. You inherit this, and the other organisms in the environment too. But from the point of view of what we're going to talk about mostly now, the fact that organisms altering their environment can produce this inherited environmental improvement, something that can give them a better capacity to reproduce, is a form of evolutionary capacity. So this is, I would say, what's rapidly becoming the mainstream view in ecology about evolution, is with niche construction in here, you have a two-way street. Organisms can alter their environment, and then they have to adapt to the environmental alterations. And of course, it's very complicated in an ecosystem, because you have lots of different organisms altering the environment, and they all are adapting to these alterations. But just this idea of the two-way street very much complicates the view of evolution and ecology, and is really necessary to understand species that are ecosystem engineers. So if we're going to understand humans, we need that. Another thing we need, also not unique to humans, but is necessary to understand the evolutionary processes that have given us these exceptional capacities, is the concept of social learning and cultural inheritance. Okay, a lot of species have behavioral traits that they need to engage in and learn from each other. Social learning is learning from each other in order to reproduce. And this is an example of this sparrow that must learn its mating songs from others in the environment in order to reproduce. If it can't learn these songs, it can't reproduce. So this is a cultural inheritance. It's learning from others how to do something, and then it's providing an adaptive fitness. So this is cultural inheritances and the process of social learning. And there's a lot of species that do this as well. There's a new theory that puts all these things together. And this is called the extended evolutionary synthesis. If you haven't heard about this, especially if you're in the biological sciences, I highly recommend you read some of these papers. Dan Chin's paper is especially good on this. The extended evolutionary synthesis basically takes the modern synthesis, which is the core of modern biology, right, which is the simple example we started with, right, genetic inheritances. That's what evolution acts on. Okay, and so we have that over here. And we often think of that very simply because for us it is pretty simple, okay? Inheritance is vertical. You inherit genes from your parents. You can't inherit them from you and I, right? We can't do that. But guess what? It turns out it's really common for a lot of organisms. Bacteria, they get genes from each other all the time. They have horizontal inheritance. Bacteria do. You put two bacteria together in a medium that has an antibacteria chemical in it, And the resistance genes will pass from bacteria to bacteria. They can actually horizontally inherit. Okay, so that's one element that's added in to the modern synthesis, is horizontal inheritance. The other is these other forms of inheritance. And epigenetics was probably the first reason why people realized they couldn't get by with just genetics alone. And that's because gene modifications, methylations, different properties that are added on, usually by stress effects and this sort of thing, can actually modify the activation of genes. And in some cases, this activation can be passed on across generations. It's a little bit like the classic Lamarckian inheritance, where an organism can take a trait that it gets in one generation and pass it to the next. That is actually somewhat possible. It's not a huge effect, but it's occurring in a lot of cases. So that's epigenetic inheritance, only vertical. Parental effects in utero, this sort of thing, or another thing that needs to be included as other forms of inheritances. And over here, then we finally have ecological inheritance, right? That's the niche construction process. And we have cultural inheritance from social learning. All of those together form a vector, a suite of genetic and non-genetic traits, epigenetic traits, that together form the inheritances that determine the behaviors of an organism. And for us, of course, this one's pretty big. Notice that in cultural inheritance, obviously, right now we're doing it. Right now we're passing information horizontally. Right? You guys are all learning this. You can pass it on to your children. And that would be a oblique inheritance. So those kinds of inheritances, the nice thing about those is they're very fast. One of the reasons why bacteria have it so good, why they're still around, why they're still doing so well, is they have horizontal inheritance. That's really fast, right? Instant. You don't have to wait for another generation to come along. Okay, so we've got that complicated extended evolutionary synthesis under idea here. And there's just a couple more concepts, and then we've got the whole sociocultural niche construction idea. Sociality. Also, nothing new about sociality, right? Social insects. There's even highly social mammals like the naked mole rat that are very much like this. Properties in which an organism is actually not reproducing individually, but it's reproducing as a group. So you have group selection, right? The queen is the only one that can reproduce. You have some of the factors of the organism is producing a protected nest, and some other properties that together give some capacities to that organism to evolve that just have to do with cooperation. But all this cooperation, in the classic view, is genetically determined. It's determined by behaviors that are genetic, not socially learned. Okay? So what's really interesting about people is we have socially learned sociality. It's not genetic. We have the fact that we're social, that's genetic. But the way that we're social depends on what we learn from our culture. So that is the really distinctive element of human sociality. The other fact is that we are able to pass our cultural inheritances on so effectively from generation to generation, mostly because we have language, that we're able to keep that transmission going very effectively, which allows culture to accumulate. It's called cumulative culture. And of course, our culture evolves. Just like genetic traits evolve, cultural traits can also evolve. Putting that together, humans fall into this special category, and it really is unique. There's no other species that has culturally defined social organization, right? You can't tell. You take a biological individual, you cannot tell what that person is going to do. You need to know the culture. Culture is essential for understanding what humans do. We also do some other things that are relatively unique. In a beehive or an ant colony, right, you're seeing a lot of sharing. One insect is collecting the food, the other one's eating it, they're sharing. Humans do that with non-kin, with unrelated individuals. You have done this today. This is the basis for human sociality, is non-kin subsistence exchange, right? You regularly depend on relations with total strangers, unrelated strangers, in order to survive and reproduce. That's also really important to this idea of ultra-sociality. So, we put this all together. We have an ultra-social organism, right? It's doing everything socially. It's dependent on culture. It's not just social. It's culturally social, right? The culture defines how we interact with each other, what our social relations are, where you're going to get your food. And we also engineer our environments. And we engineer our environments using socially learned, culturally inherited practices. That is sociocultural niche construction. We have a socially constructed environment. And that continues. This is another example, right? This is a social relation that involves constructing the environment. So, if we put all this together, we get a relatively complicated model. If it wasn't complicated enough just to have niche construction in there, we now have to include the social system, which includes cultural inheritances, and I've added even another element here, material inheritance. Okay, the cultural inheritance is kind of obvious, right? It's what we've learned to do and what we can teach each other. But we also have the physical infrastructure, like this building, right? This is going to change what this society can do. And it's a material thing, it's not actually a information thing alone. So those two elements, cultural inheritance, material inheritance, give societies some special traits that are rare outside of human societies. And that social system is going to interact with the ecological system to construct the niche. Okay? And that's the basic idea of anthroecology or anthroecosystem production through sociocultural niche construction. I think I'm missing a slide. Out of order. Let me go back to this. Okay, so there's also change, right? These societies are changing and we're evolving. We're seeing these societies are evolving over time, and of course, the environments and ecologies that are transformed by these societies are also evolving. They're all evolving together. Evolution by natural selection is a pretty basic thing, whether you add in all these different elements or not. And the simple thing is you have relatively gradual accumulation of inheritances. You have slow innovations, and the innovations get accumulated if they're adaptive. And that's a relatively gradual process, okay, gradual changes. But you also have relatively dramatic changes sometimes. And that usually goes along with, could be a big change in technology, such as the plow, which enables new things to go on. It could be religion. And in the case of where these things really come together, you get the biggest regime shifts in these anthroecosystems or sociocultural systems and ecosystems. You get the biggest effects when these things go together. A new religion, a new technology, a new environment, all these things together, and that's a major change. Now, one reason why human societies change so fast, why we see these big changes, and why we've changed at a level that is dramatically faster than other organisms, is because culture tends to evolve faster than genetic traits. And even Charles Darwin, he actually made a point about this, that culture evolves quicker than genetic traits generally. It's not always true. There's some examples that are not the case, but generally this is true. Why is this true? Well, we just remarked earlier that if you rely on these horizontal or oblique inheritances, right, and we're doing the horizontal right now, it's very fast. It's much faster than if you have to wait for genetics to take place. So that's one obvious reason. The Ratchet Effect is another one, and that has to do with the fact that with cultural traits, it's very easy to build one trait onto another. And the classic example of this is, say, people use the bow and arrow. So the bow and arrow is comprised of many smaller traits, right? You start off with how to make stone points, and then how to make an arrow, and then how to glue the things together. And when you have those things, that's a spear, then you can invent the bow and arrow. You're just adding on. You don't have to invent all those things separately. They ratchet up. They build on each other. So that creates an acceleration effect as well. And then the final one is kind of what got us into the big trouble, is runaway sociocultural niche construction. And the idea here is when humans alter the environment to a certain degree, they're producing a kind of environment that they already have to adapt to. Okay, so let's take an example like agriculture. You start tilling the soil to survive. Okay, so after a time, your society becomes dependent on this, and you basically need agriculture to survive. Okay, so once that takes effect, then usually that modification is going to have consequences. The soil erosion takes place, or the soils become less fertile, and then you have to adapt to that. And with that, you have to adapt with more culture. You become dependent on even more agricultural techniques in order to survive in that altered environment. So once you start altering the environment, you have to start living in that altered environment. Maybe the scariest scenario of all is we start altering the atmosphere with carbon dioxide. Well, we already started that. And then we realize, well, we can't stop burning fossil fuel, so let's start geoengineering the climate system. Then you become dependent on that, and then something else. So that's what we've been doing for a long time. If we look at the really big, and the nice thing about looking in the big picture is you can use evidence across deep time. And with that, you can look at this graph. Now, this graph suffers from one problem that I'll discuss in a minute. But it gives you a general idea. There's some general trends in the long-term changes in human societies. And we'll talk more detail about those, but what we're basically looking at here is these big, what I would call meta-regime shifts, the really big changes in human society, starting with the small bands of hunter-gatherers that were the first societies that humans formed. And they've changed in many different ways. They've changed in the amount of ecological inheritance that they depend on, right? More and more modification of the environment as societies become more complex. We won't call them more advanced. More and more material inheritance, more cultural inheritance, and overall dependence on sociocultural niche construction. Early on, it was just genetics. Whatever you inherited genetically, that's what you depended on. That was the big effect on your adaptive fitness. But over time, these other effects have become more powerful in determining the success of individuals and societies. But that's a kind of a simplistic graph, right? It looks really complicated, and it is pretty complicated, but in reality, it simplifies everything to look like it's a progression. There's no progression, right? Anyone who knows about evolution by natural selection is that it produces this. It produces a really complicated set of related organisms, or in this case, related societies. They're all related, we know that. That's one thing that's simple about it. But it's not simple to say what's going to happen. There's no predictive ability, and there's a lot of extinctions. It's not a simple process. It's not as simple as going forward and linear. And a great example is the cockroach, just because it's a very old evolved species, it's got hundreds of millions of years, is it not a fit anymore? Actually, it's probably doing better than ever, right? So there's nothing about being complex like us that makes us better or more fit or something like that. That's just evolution. And cultural evolution continues. We may not see it as much as we think it's there, but it's very much there. And of course, there is extinction. Maybe that's a good thing. Anyway. So the grand trends, some of the big trends we see. Now again, it's not a linear progression of change. It's not a simple process. But we do see some general trends. And one of them is the upscaling of societies. Societies thousands and thousands of years ago were much smaller than the societies that are formed today. Okay, they're less dense. And so over time, we see the emergence of larger scale societies. Some of the large scale societies have failed. The Romans are gone. They disappeared. So it's not as simple as just this general trend that always going up. But we do see a general trend toward larger scale societies. Cooperative ecosystem engineering, the degree to which it takes a whole society just to make your food is something that you see in general too. As the societies become larger scale and more complex, they require a larger scale of cooperation just to feed a single individual. So that's another interesting property. One here, very dear to Peter and I, land use intensification. We see increasingly intensive use of the same environments to supply societies. And we'll talk in detail about that one because it's particularly interesting for the future as well. And energy substitution, that's the other one. And energy substitution is why right now we can all afford to do this, and we're all out there growing our own food or something like that. We have substitute energy. We have all this fossil fuel doing all this work for us. So with land use intensification, if you're agricultural economists, you know exactly what it is, and you don't talk about this. This is not something you usually talk about, but it's really important to understanding where intensification comes from. It's long before we have agricultural societies. We already have societies doing niche construction in ways that provide more food from the same environment. And the classic example of this, the earliest one, and all archaeologists are familiar with this idea of dietary broadening or niche broadening, where hunter-gatherer societies, once you've killed off the easy prey, you got most of the woolly mammoths, you've got the easy prey, you have to go for the other ones. And over time, societies learn to eat, consume, and process more and more different species. They gain this very complex knowledge of all the different kinds of organisms, and they start consuming all these different kinds of organisms. It's very easy to detect in evolution of societies. Okay, so that's one example of intensification. By this method, more people can live in the same environment. Another one is food processing. This seems kind of boring and stupid, right? It's just like get out your Cuisinart and make food. It doesn't seem very important, but it actually turns out to be the reason that we consume grain, right? The natural wild grasses, before they've been domesticated, are incredibly time-consuming and labor-intensive to eat. You wouldn't do it unless you had a scale of food processing capacity that makes it useful to consume huge amounts of these tiny little seeds. That put us on the road to domesticating the grains, this capacity to process so much grain. Another one, and this is where we get into what we call the proto-agricultural intensification, is the burning of landscapes to increase their productivity. Before you have agriculture, it's still really a good thing to burn a woodland to open it up, to attract game, and the plants that grow up in those environments are more productive. And so hunter-gatherer societies generally will burn the landscape. Not all of it, but they leave open patches all over the place. So that's another intensification. It looks a lot like agriculture. And then finally, domestication, gradually occurring. More food from the same land. This is what agriculture looked like back in the time that we're talking about Bill Rudimann's hypothesis. Okay, thousands and thousands of years ago, people did not farm like they do here. Even here in the Netherlands, although I wonder if anyone could burn the forest here in the Netherlands. But in a lot of areas, this is the way you did your agriculture. You burned an area, you'd plant it, you might harvest there maybe at most 2 years in a row before the land gave out, and then you burn another area. And the reason is, it sounds like a lot of work, but actually it's much easier. It's much easier to do this than it is to till the soil and plant crops into the ground. It's much easier to do this. And so this was the most common form. So a very small number of people needed a large amount of land, burning it, in order to produce enough food to sustain themselves. So land use intensification really, now this is the part that's familiar to all agricultural economists, is this idea that when you start off with low population densities and low demand for food in a given area, people are leaving these long fallows. They're only cropping every 25 years in a lot of cases. They're not coming back to the same land. There's no shortage of land, just burn some more. But over time, when there's less land, they're using the land more often, and then ultimately you end up in these really intense cropping systems that I worked in somewhat, where people are growing crops, 2 crops per year or 3 crops per year, using the most labor-intensive technologies you can imagine. This is backbreaking work. Nobody wants to be a traditional farmer anymore, except in people's minds at the university. Right? You don't want to do this. This is hard work. These guys are so glad to be done with this. It's not necessarily a form of progress that we can produce more from the same land, especially with these traditional plantings. But this is something that you'd see. It's a general trend as people have to work harder and they produce more out of the same land. So here's this trend. We talked first about energy substitution. Really, it's just biomass fuel starting off early and going all the way to almost the present and using more and more. Now, biomass, you don't think about cooking with firewood maybe as being energy substitution, but it actually is. It substitutes for human biological energy for digestion. Cooking your food is actually a form of substituting your own energy for, substituting biomass burning for your own biological energy. As we start to make metals and this sort of thing, we're burning a lot more. And then finally, we get to this revolution where we learn to burn the ancient biomass from a long time ago, right? Fossil fuels, and are able to expand our burning of energy and energy substitution. And now we even have even more dramatic forms in some ways. Now, some of these are actually kind of old, especially here in the Netherlands, right? Wind power is not new to the Netherlands. But there's abiotic energy not dependent on the biosphere, right? It could be almost unlimited. The biosphere is very limited, but energy outside the biosphere, nuclear energy, solar energy, these are not limited by the biosphere. Then we have the intensification process. How much ecosystem does it take to support a person? Well, in the good old days, when you weren't transforming the ecology of places very much, it actually took a lot of area to support an individual, right? So you're using a lot of land, but you're not changing it very much, right? You're just pretty much just harvesting a little bit. Over time, we learned to enhance that, clearing out the landscape with fire and this sort of thing. And so we're getting a more transformed environment, but we're using less per person. Now, this isn't the total use for a society. This is the use per one person in a society. Societies get bigger, even with more efficiency like this, it can still use more land. But nevertheless, over time, as we learn to transform the environments more and make them more productive, croplands are much more productive in supporting people than a wild forest, we use less per person. So strangely enough, we might think about modern societies as the most wasteful in the world, but in fact, they're the most efficient societies for using Earth's land that have ever existed. So that actually explains this Ruddiman trend. Going back to that trend we had here, right? There's no people back then. 7,000 years ago, there's hardly any people, very few. How is it possible for so few people to use so much land, to clear so much forest that it would actually affect Earth's climate? And the interesting thing is, if you consider intensification, the fact that people used a lot more land per person, that's the top one up there, land per person. If you use a lot more land per person in the past, right, and then as populations become more dense, you're using less land per person. Interestingly, when you put these population curves together with the intensity curves, you actually can show that rates of deforestation actually peaked thousands of years ago. The rate of land clearing peaked a long time before the current time. And it actually can explain to some degree why a small number of people could produce this big burst of carbon emissions thousands of years ago when there weren't that many people, and why it didn't just continue to keep going up from land clearing. So that's just an interesting explanation where you have to understand a social process of environmental change in order to understand climate change. And if you actually do the modeling with this, and this has been done by, I think it's no, I don't remember his first name. But anyway, this is a global model that includes the agricultural land clearing from that Ruddiman model that we just saw. And you can see that based on that, you get a very significant, more than half a degree change in the pre-industrial period. Now, you have to remember that even though that's a pretty significant change, it's about as much as we've done in the industrial period. We're talking about maybe 5,000 years of change, not a few decades of change. So it's a massive difference in rate. It's very slow, this kind of change, but it's significant. But from my view as an ecologist, I'll get back, I talk about climate mostly on demand. It's not my main focus. I'm mostly interested in when humans transform environments, what do they do to ecology? How do they reshape the ecology of the Earth? And so that's where I started this effort. And this is a graph or a map that's too complicated really to understand fully just by looking at it. Again, it's in that paper you can find there. But what the idea here is that different societies, and you see there hunter-gatherer societies, horticultural societies, agrarian societies, industrial societies, transform environments differently. And they don't transform them, not only is the different societies producing different environments, producing different landscapes, they also have different social patterns by which they modify the landscape. So I'm not going to get into the details, but you can see this idea of centrality. In central places like cities, people do different things to ecology than they do far away from cities. And that's true even with the early societies. The bottom line is, using this kind of a sociocultural niche construction model, you can predict to some degree what kinds of patterns different societies would produce, and you predict that different societies change the environment differently. It's not just about one person, one impact. Much more complicated than that. Different societies produce completely different changes in the environment. It doesn't have to do necessarily with population density. That's just part of it. So we're back to human transformation of the Earth, this idea of anthropogenic biomes. So now what I want to talk about is this ecology that has been shaped. So just looking at the state of affairs that we have. So we have this anthropogenic biome situation. And if we look at the conditions in which people live, most people are living in the denser populated areas. And that's, of course, increasing over time. Everyone knows, right, the urbanization is very dynamic right now, and people are increasingly living in the city. But even this was year 2000, about 80% of all the people on Earth live in the most densely populated types of anthropogenic biomes, urban areas and villages. With land, only about a quarter of Earth's land, and this is based on estimates from global data sets, areas with no evidence of human population or use of land, only about a quarter of the world is in that category, and we're calling that a wild land, no evidence. Doesn't mean there's no one there, though, in reality. And about 3/4 of the terrestrial biosphere is in some transformed state. It's not all the same, right? They're very different types of transformations. But one interesting statistic from the point of view of ecology, and most people think of wild forests as nature. There's a common thinking about that, especially among North American ecologists. Well, if you look at the existing area of wild forests on Earth today, that is actually less than the area of cities and villages today. So if you're interested in Earth's ecology, you've got to be just as interested in that urban and village ecology. It's just as common. If we're looking at the shape of the biosphere from the point of view of productivity, okay, the primary productivity, Earth's plants take in solar energy, and they produce the energy that all of us animals have to use. So that's a pretty important description of the biosphere, net primary production, this energy taken in by plants. Well, only about 10% or so of that process is occurring in areas without any people. Most of it is occurring in these anthropogenic biomes. And that's true for a pretty simple reason. Most of the areas that people are not in right now or using are not very productive, right? We are not in the Sahara Desert. We are not in Greenland. So there's a lot of areas that really have very low productivity. Those are the most important wild places we have left, right? And the places that are more productive, we are using a lot of it. So wild forest primary production is actually less than the primary production that goes on in these densely populated anthromes, which is pretty amazing when you consider that forests are the most productive forms of ecology. Less than 20% of Earth's tree cover is within the wildlands, and more than a quarter of Earth's tree cover is embedded just within croplands alone. So when you think of cropped areas, and you look out of the airplane here, you'll see it everywhere, right? There's trees there. It's not just crops, and that's very true of anthropogenic biomes, is that they're mosaics. They're mixtures of things. And so you end up with this kind of strange effect. So if we look at the terrestrial ecology of the world, we have about a quarter of it that doesn't have any people in it and doesn't have any land use. And we have about 40% of Earth's land that is either cropped areas, pastures, or cities and infrastructure. Okay, that's about 40%. Those are two simple categories that we can understand. But then we have this other weird category, and that's the stuff in between all that used stuff. If we went out there and used all the land in a place for production, it wouldn't be so complicated. But what we do is we create these mosaics. And I'll describe that in a minute. But the biosphere that we really have is some of it we could still protect in its kind of more intact state because it hasn't been used before. Some of it, if we're not going to use it, we're going to have to take it from somebody or buy it from somebody or something like that. And then you've got this mix in between where it's essentially ecology that's been embedded within the used landscape. And again, this is because of this idea and this fact that if you go look at landscapes, you'll find that embedded within the used mosaic, you have less used areas. It could be forests, it can be a lot of different things, abandoned lands. They're common all over the world. They're common in almost every environment. Some areas they're more rare. Essentially, wherever you have either wherever you have complete use of the environment, say the Midwest of the United States, it's all crops, or the Sahara Desert where it's all wild. Everywhere else than those places, you see some mixture of used landscape and less used places. And this is just an example from China where I was working. And this gives you an idea of just kind of how complex and messy it is. If you say this is a forest, well, I think it meets a lot of definitions of forest, but it is not a place that you could understand the ecology of without understanding the social processes that produce this forest. You have some of these trees are planted from some other country. Some of them are just regrowth. Some of them are continuously harvested. People are chopping the limbs off. They're all managed by people in some weird way. So when you think about the ecology of the Earth in the Anthropocene, you can't just think, oh, well, we have natural forests are remaining, and then that's the other part is used. It's actually a much more complicated thing. When you talk about a forest, you have to think about the human social shaping, the human purpose of that forest, because that is going to change the ecology of those places. If you just say, well, it's an oak hickory associated forest, well, if you don't say, well, it's actually a woodlot in somebody's farm, you won't understand the ecology of those forests. And as I said, novel ecosystems are common all over the world. Again, everywhere where it's not totally used or totally unused. You see different amounts of it in different places, but they're extensive all over the world. They have very different ecology. One of the classic things, and anybody here who has had, if you've ever been involved in managing a conservation area, a lot of people talk about the big concern is extinction. And it is a big concern, and it's partly a big concern because it's relatively permanent. You lose a species, you can't necessarily get it back. But the big effect that you're seeing is invasions. That is actually the biggest effect on ecology. If you're managing a conservation area, invasion of species is incredibly transformative, and it's occurring all over the world. And it's one of these things that's driven by the fact that there's human-used land, there's human infrastructure all over the place. Even in areas that aren't directly used, they are highly influenced by that movement of species. So we're at the final part of the talk where I get to talk about maybe this future part. And I have a kind of a future post-industrial area there. It's just an idea. We don't know what the reality of the future is. But let's just take a look at some of the potential for the future. Are we is this an apocalyptic period? Or is this a period where maybe we might do something? Well, when you see something like this, you might think, oh, well, clearly apocalyptic. Right? This is urbanization in a third world country. It happens to be China, but you see this all over the world. It's not necessarily beautiful. But if you ask the people there, most of them are going to say, I'm happy I'm in the city. They might say, I miss the farm, but generally people are upgrading by moving to the city. There are some cases where people are being forced to move to the city, but that's the rarity. Most people are going voluntarily because that's where the opportunities are. It's a huge transformative force, and we know it's going to keep unfolding. Next few decades, we're going to see more and more urbanization. This has a big effect outside the city. The biggest effects of urbanization are happening outside the city. They're changing the scale at which humans interact with environments. When urban people interact with the environment, they do it by the millions. They don't do it a little bit at a time in the countryside. They do it through their demands on the marketplace, and the market responds by this. The market responds mostly with larger scale production systems that actually are more productive per acre, per hectare than the traditional systems. And if you look at that, Paul Ehrlich in the 1970s said, we're going to have mass starvation. And at the time he said it, it actually made some sense. It wasn't a totally crazy thing to say. He happened to be totally wrong, as we know, because what actually happened is that food production per person went up. It went up almost continuously in the decades following the 1950s through green revolution technologies and intensification and larger scales of agriculture. And you see this relatively rapid increase in food production per person. So people, it turns out, are better fed than they've ever been in history. And that's continuing to improve. It's not improving for everyone equally, but it's a remarkable trend. It's not the trend that anyone predicted. And it's because of agricultural intensification. Even more remarkably, now this trend ends in 2011, and actually total amount of Earth's land being used for agriculture is increasing again. Not that rapidly, but it's not just steady there. But it is remarkable that much more food is being produced per person, while total amount of cropland is not going up that much. So that is another remarkable trend. Okay, so this intensification process means that it's not as simple as the fact that we're going to have 10 billion people in 30 years or 40 years. That fact isn't as disturbing as it would be. Imagine if this didn't occur. Imagine if there was no intensification. Every added person means more trees need to be cut down, more cropland. But that's not the case. It's not so simple. In fact, what is being seen in a lot of countries, and it definitely depends on where you are, you're actually seeing a lot of recovery, a lot of abandoned cropland. And I've seen this all over China, for example, which is a place you wouldn't necessarily predict that because you have a much bigger demand for food than you ever did there. Yet at the same point, forests are recovering. Now, forests are getting cut down in some other places, but the bottom line is there's a real potential for there to be more recovered ecology and less use of agricultural land in the future, depending on policy, depending on whether these intensification trends continue. So that's a remarkable thing. So when I show this slide, a lot of people, especially ecologist colleagues, they take a step back and they're kind of like, oh, it is the end of the world. This is the apocalypse. But there's another way to look at it. So we're the most social species ever. Not only are we social in our behavior, we have to learn our social behavior from others. We socially learn our social behaviors. We're incredibly social. This creates new capacities to do things. The fact that we're all connected together, we're more and more connected over time. We are the most connected human societies that have ever existed on Earth. We have more social capacity to do things one way or the other than we've ever had. We can act at scales that we've never done. Is this the time to take a step back and say, oh no, we can't do anything? I find that remarkable. I've seen that many times. People are like, well, we're in this kind of crisis, we can't do anything. It's not true. We have more capacity to change the world, for better or for worse, than we ever have. So never say we can't do anything. We can do more than we've ever been able to do. The really hard question for me, and I think it should be the question that a lot of us are asking at least, is what kind of biosphere, what kind of Earth do we really want? We're often thinking about, look, how can we stop the end of the world? I mean, that's a pretty crappy way to look at the future, and it's not going to get you anything better than what you have now. Just trying to stop everything from happening isn't going to work. Is there a vision for where we want to go? Now, of course, you see there I've put in quotes, the we. There is no cockpit on planet Earth, right? There's no place you can go. There's no group that is in charge. That's a big challenge right there. Maybe that's good. Maybe it needs to come from the bottom up. Maybe it shouldn't be through a cockpit. Maybe the social process needs to come from the bottom. Either way, though, if we're not thinking about the future and how it could be better, we're only thinking about how to stop the worst, I don't think we're going to get very far with the Anthropocene. We don't have every opportunity. We're not starting with this, if we could just save the wild planet, then we could save nature. The wild planet's mostly gone. We live on a used planet. This is a planet that's secondhand, used before. What can we do with that? That is the reality of what we have. We're not going to save it. We can improve it. We can rejuvenate it. We can restore it. We can manage it better. Those are the real possibilities. We're making it very, very hard to do well by the biosphere. Right now we have a rapidly changing climate. It's going to accelerate. We have not seen the beginning of climate change compared to what we're going to see in 25, 30 years. It's really going to start getting impressive in the future. And everything on the planet is going to have to move, except maybe in some of the tropical regions. Species are going to have to migrate to keep up with where their habitats are going to be. Species are going to be moving north. That is just a reality of our future. Okay? That's something we have to take into account. It's not optional anymore. Species are going to have to move. And we've made it incredibly hard for species to move. Like, this is a classic example of a kind of human infrastructure development. But even though this is maybe kind of a worst case scenario for how a small amount of development can block a lot of movement, this is typical of human infrastructure. We build our societies as if only our societies matter. We don't think about the consequences of what happens to all the rest of nature. But that is not inevitable, and it's not the only way. And of course, even you guys know already that there's differences in ways to do this. The key is, I think, though, to think in terms of that humans are not just destroyers. We are designers and shapers. And this is one example I bring up because you might not know this because you're not an American, or maybe some of you are. But you probably all know what this place is. It's Yosemite, one of the most famous national parks in the United States. What you might not know is that there's another valley that looks almost exactly like this, or it used to, called Hetchy Hetchy. And it was also one of John Muir was one of the people who advocated for protecting Yosemite. He strongly advocated for protecting Hetchy Hetchy. Hetchy Hetchy is now a reservoir for the city of San Francisco. It's underwater and full of sediment. But actually, interestingly, people are even discussing now, even in the case of the drought that they had in California, which is now over, whether they should restore it to its original patterns here. This is a design choice. This is a land use. So it's our decision what happens. It's not like nature just produces itself. We have to produce it. And we're getting better at it. We've learned that, certain patterns of land management, farming right up to the stream, is a really bad idea. It produces all sorts of negative consequences. That pesticide and fertilizer goes right into the water system. All right? Create a buffer. There's just better ways to work with a landscape. And it's a complicated landscape. It's not that we have to have agricultural solutions and wild solutions. You have to do it together. We've made this mosaic of used and less used and wilder places. They're all mixed together with our infrastructure. We have to manage these multifunctional landscapes. And multifunctionality is not always a good thing. It seems like obvious. Of course it's better. Do two things at once? It's always good. No, it's not always good. It's actually always pretty hard to do two things together at once. But that doesn't mean it's not possible. And I think this is common in the Netherlands now. And it's common increasingly in every place that has good land planning, is that when you build infrastructure now, you have to consider the movement of other species. And so this is just one example of how you can build infrastructure and it doesn't have to be the end of the world for all the species in the area. It's possible to design the biosphere to make it actually an effective habitat for people and for other species. We have to think big about this because right now species don't just have to move across your city. They have to move across a continent, and in the next 100 years, they're going to have to move. And so we need to be thinking pretty large scale about these kind of designing thinking. The good news is, and I think here it's a well-known thing, but in North America, there's a lot of nature is fragile is the message you often hear. Nature is not fragile. Nature is really tough. Nature is strong. Nature comes back. You just got to give it a chance, give it something to grow on. And an example I bring up in here, it's from Europe, is that in some of the most densely populated landscapes in the world, you have the recovery of a species that is very hard to live with. It's very hard to live with wolves. Yet people have intentionally brought back the wolf, and the wolf populations are doing pretty well. It's a remarkable fact. When people change their culture to decide they're going to live with a dangerous carnivore like this one, it's possible to bring species back. So this is not an end game. It's possible to completely change the game. We can rewild. We can bring back species that haven't lived in these areas for long periods, and we can restore ecological processes that have been gone. These are choices. These are design decisions. And when it comes to our own design decisions about our own habitats, when it comes down to, we can do better than this. Now, I'm not going to blame the people who are city planners here, but this is an example of urbanization that isn't scaling. And you could argue now, Netherlands is probably one of the better places. In Switzerland, where I'm living now, these are places that actually do plan for scaling up cities. They're dense cities. But as a North American, I'm familiar with the worst kinds of development where cities just go on and sprawl. Dense cities are more energy efficient. Dense cities make it possible to conserve more land for other uses, but they also, actually can improve lifestyles and all this sort of thing. There's a lot of possibilities when we change the way we live in cities. And there's possibilities for living in cities that are really different. And this is an example, and I've been showing this for a few years now, and you can kind of see that this is fake, right? This is the design drawing. How many people know that this is real? You ever heard of this? Good, I'm glad I'm introducing. Yeah, you have. You've seen it. So it actually is real now. It's been built. And what I thought was kind of interesting about it was that this is the way they maintain it. This is the real thing. They actually have people that actually rappel down from the top and maintain the vertical forest, it's called. And I'm not saying this is a good idea. It could be a bad idea. This could be, it looks green, but it could be very not green. It might take a lot of energy and resources, and it's not actually a good idea. But it gives you an idea of different ways of living in the city. And it's a kind of idea that you don't have to give up everything just to move forward, right? If we're going to live with 10 billion people, maybe this is a better way than having everyone sprawled out horizontally. Either way, we have to come to terms with the new reality. Social species have lived on the Earth for a long time, and they've shaped the landscape profoundly. If you've ever been to places in Africa, for example, where termites are reshaping the landscape, this is a social species that transforms the ecology of areas. We have a new species that is social at a scale that has never happened before. It's a novel process. We don't really know where it's going, but we can guide it to some degree. At least it's possible. We have to think about the possibilities, not the end game of what humans are doing to the Earth, but what the possibilities are, because we're not going to go away anytime soon. We have to think about the Earth as not a place where humans are some kind of problem and separate, but rather humans are an integrated part of the way the Earth functions. They're part of the anthroposphere they've added into the Earth system. We have to get beyond this idea of this kind of balance of nature where everything is kind of provided by nature and get on to the reality that really what we have now is we have an entangled relationship with nature. When we move, the biosphere moves. We are entangled together so deeply that there is no extracting ourselves from the rest of the Earth. There's just different ways of having our relationship. Hopefully we can find a better way. And one of the things that we've learned with all the new sciences, one of the more exciting discoveries, is this idea of the microbiome and what it does. We are all connected. You are not 100% human. You're about 90% human. And the rest of you is a whole bunch of microbes of different kinds, a whole ecology going on inside of you. And we're connected together. As I talk, I'm moving a little bit of this out to you. My microbiome is mixing with yours a bit. We're all connected together through the biosphere. We're not separate. And so we need to think of the Earth that way. Thank you.
Thank you, Erle. Great talk.
Oh, thank you.
You tell us why we transformed the Earth, why humans transformed the Earth and climate. Anybody still present to ask a question to Erle? Or so baffled?
Knocked everyone out.
Jared.
Yeah, it was very nice when you were putting together all these different systems, let's say, to make it more transparent. It's interesting if you want to change or have concepts to change. You have to know what are the triggers for the change. And I think what I missed a bit maybe in the talk, but maybe we can discuss or we take it up later, is how to influence the economy. Because everything we now do, or nearly everything, is driven by economy. And as long as you don't have an economy incorporated into the system as one of the major players, let's say it in a positive way, if you convince economy to think of these dimensions, then you have a chance to change it much more rapidly.
So that's an interesting kind. I agree to some degree, but I would call the economy the human weather. It says more about how we interact directly, powerfully, day to day, from year to year, right? It explains those processes quite well, and you could argue that you could even say it is those processes. But if you look at what happens over 100 years, and you look at what happens in different societies, not just one global society, which is kind of a fiction. It's something we've made. It's actually culture. The way our cultures change actually shapes our economy. And changing culture is a much more, nobody knows how to do it exactly. It's an interesting subject. It's becoming a very active area of study is cultural evolution, cultural change, a multi-level cultural evolution, which is the idea that culture occurs at two scales. You have to think about individual culture. What cultures do you use to survive as an individual, to succeed as an individual, versus what cultural aspects help your societies succeed, help your social groupings succeed against each other. All these levels of culture are part of cultural change, and if you don't consider them all, you can't understand them. But I would say that the trick to the really big changes is the socio-cultural change.
Thank you. Other questions?
Compared to the other species, what do you think what effect or control the culture accumulate? Other species cannot record and writing because we can writing, we have language, we can, which make us become very important on Earth. What effect or control this compared to the other species?
So you're asking, so we were talking before about cultural accumulation. So humans have this ability to accumulate culture to a higher degree than any other species. There's a lot of species that learn socially from each other and even can accumulate a little bit of culture. Over generations, they can accumulate culture to some degree. But humans do much more of it. Yeah. And this is a very active subject of research. There's multiple hypotheses. I would say the jury's out, truly out. Like, there are people in this area disagree strongly with each other about this. So that's a subject you're going to see more of in the future, is why are humans able to accumulate culture so effectively? But I'm leaning with the people who say it's language. It's humans' ability they call it high fidelity communication. So when we transfer a trait, you've played the game of telephone, right, where you tell somebody something and then they have to tell someone else and tell someone else, and after some time they're saying something completely different. Humans do that better, though, even though we're not that good at it either. Humans do that better than any other species. They can't communicate very well. So language is a big thing.
So perhaps just a quick comment building on that. I don't know if there's a question somewhere in here, but another thing that I guess sets us apart as a species is that we have intersubjective institutions. So we believe in things, and this believing in things enables us to do things such as building pyramids or coming up with different kind of economic systems, which is not possible unless there are multiple individuals who are believing in the same thing. I mean, this applies to economy and money as well. Now, you were saying that the economy is like the human weather. I tend to disagree with that because that implies that it's something out of our control that just happens in the objective reality out of those intersubjective notions, whereas that's something that we can very much affect. And I agree completely that the social cultural change is like the real issue. But maybe related to that, I mean, that's the hard part. How do we envision such a massive sort of social cultural changes in the future that might help us to change our systems in a way that are more sustainable, instead of just sort of trying to adapt to the conditions?
So that was two questions. The first was about what you were challenging the idea that sociocultural processes create or shape the economic process. You were saying maybe the other way around, or?
Yeah, so I'm saying that sort of economy.
And they obviously go back and forth.
Yeah,
and they feed back.
As much of a sort of a intersubjective social structure or construction as many other aspects of our sort of culture. So there's nothing there that is outside of human culture and art.
Well, here's one thing I'd recommend. Let's talk about this again. There's a paper, if you haven't heard of it, In Search of Homo Economicus. Have you heard of that paper?
No.
Highly recommended. Any of you want to read a great paper. That's one of the classics of all time. In fact, the guy who wrote that paper got a job at Harvard doing whatever he wants.
That's a good job.
Yes, it is a good job. Joe Henrich wrote that. He wrote a great book, too, called The Secret of Our Success. What they did was they played games, different types of these economic games about trust, about valuation, across, I think it was 100 different societies with really different ethnicities, right? Like Polynesian, indigenous societies and stuff like that. And they found there's no truth to the idea of a rational agent. Like, what rationality is cultural. It's learned, it's socially learned. So the idea that you could have an economy, you couldn't have a trade economy without our culture. And cultures that don't have it aren't interested in it. They don't need it. But when they get it, they want it. And it's not as simple as that, like everything's a two-way street, right? Once you start adapting the economy, your culture is going to adapt to that economy as well, right? It's never as simple as like one thing controls everything. You always have to think multi-causal about anything in human societies. But I think if you look at over the long term and globally, right, the big picture, you do see social shaping of economies, and vice versa. But it's not as simple as just the economy shapes the society. For the idea, what do you do about this? So let's just pretend that it's true that it's not really the economy, it's our social culture system. It's the way we've learned to be social. It's our social relations that we've established through what we've learned and how we behave with each other. How do you change that? And the truth is, it's not easy. We know that. But there are some insights about it. Now, the person who's probably worked the most on the evolutionary ways of thinking about social change, besides Elinor Ostrom, is David Sloan Wilson. So he's written some interesting things. He's got a book that just came out called Does Altruism Exist? And it's a good book for understanding multi-level selection, because that's the key to understanding any type of cooperative behavior. Whether you're talking about ants or whether you're talking about humans, you have to understand, it makes it really complicated, but it's the reality that, this is the simple quote from the book, and there's a paper similar to this. It's selfish behavior rewards individuals, altruistic behavior rewards groups. And they're both going on at the same time. So within a society, being selfish means you cheat and this sort of thing, and it's good for you. It's good for an individual to do that, but groups that have a lot of cheaters fail, and groups that have more altruistic behavior succeed in the face of other groups. And so that both things are going on all the time. It's a constant interplay of these two things. So to understand social change, you have to understand the different levels at which competition goes on among groups and among individuals. So you could say that's maybe it. So the societies that are successful in the face of other groups will succeed. So it's not going to work to just have altruism by itself. It has to be in a context where social groups are able to succeed as a result. But there's definitely no simple answers, and I don't have any simple answers with it.
Christine, and then Petra.
Thank you very much for your talk. It's interesting because you're kind of addressing two audiences here, because we brought together people from Earth and Life Sciences and from the environmental humanities. I'm in the humanities part, so I work on cultural history and the transmission of texts, and so I study the culture part that you're talking about, and I sense from your talk that you usually address ecologists, Earth and Life Science people, to convince them of the importance of culture. And for me, it was very interesting to see you bring in culture, but also quite defamiliarizing in a way to hear you think about culture in a very evolutionary way, to kind of fit it into the systems that you already have in place, drawing these wide lines, wide landscapes almost of thinking about culture. I was wondering if you are working with people from the humanities who have been working on cultural change and historical change from a cultural and social perspective for a long time, and if you are able to fit their work into your model, or if their work maybe has triggered you to rethink your model in some ways.
That's a good question. So we actually met at exactly that kind of workshop. When you
Sort
say
of, yeah.
it was more or less humanities, and
Rachel Carson Center. Yeah.
I mean that people in that context were coming from very different directions. So that was one example. And niche construction was the kind of the idea that was bringing people together, because we were thinking about it in very different ways. I would say that the closest I have come to really truly working in that area is not truly humanities, but it's where humanities and anthropology overlap, because that's an interesting kind of overlapping area. And we have a paper that hopefully will come out pretty soon called The Anthropocene Divide with Andrew Bauer at Stanford. He's in the anthropology department there. And he's an interesting guy because he's an archaeologist who does dig. So he physically works. He's not just writing stuff. But he's also very capable.
So I think it could be physical work.
Well, hey, these days, man, I'm mostly writing stuff, so that's not a criticism. But it's a different way of working, you know what I mean, than people that are really physically working with material objects all the time. So he does both, and he's very good at speaking the kind of postmodern language, which I am not good at doing at all. But that's been a very interesting interaction, trying to understand kind of how the natural scientific world I wouldn't say willfully misunderstands, but desperately misunderstands social process. Like just from the get-go. It's like, you know, there's not a whole, there needs to be a lot more learning on the natural sciences side about that element, about, you know, how different the ideas are. I mean, the Anthropocene, I didn't talk about the Anthropocene all that much, partly because, you know, I've been doing it for too long. It's not as exciting for me anymore. But one of the things that you really notice when you hear, and I work with the Anthropocene working group, which is, you know, there's one archaeologist, or two archaeologists now. Basically, it's mostly a natural scientific discussion. And the concept of humans doing things is, you know, all the time. It's always humans do this, humans do that. And as we know, humans don't do anything, right? You can't tell what a human's going to do without the culture. You just can't. And it's a socially differentiated process. You can't look at humans changing the earth, right? There's all different societies and social processes and social groups that are changing the earth in lots of different ways, and some aren't changing it very much at all. So you need to think about that, to think about the human. That's been an important process of really understanding how important that is to understanding human.
Okay, last question, Peter. Third question. Yeah.
Yeah, my name is Petra. You introduced a lot of concepts very creatively, creating all sorts of systems. And I think one of your main concepts is this niche construction. And you said it was the result of ecosystem engineering, basically. And I was looking at it and I thought, what is it more than agriculture and landscape management? So maybe you can elaborate this a little more. I think it means more, but I'm just trying to grab it.
Yeah, I probably didn't talk as much about, so a bacteria that leaves some sort of chemical residue in its environment that decreases its ability to reproduce in that environment. Strangely enough, that's also ecosystem engineering, because it's changed the environmental conditions in a way that will affect other individuals and its future, right? It can't live in that environment in the same way. So strangely enough, that's ecosystem engineering, and that would be called a negative ecological inheritance. The bacteria has made the environment less productive for itself. So pollution is another example. You know, human-caused pollution is ecological engineering, and because one problem with this term ecosystem engineering is it sounds very intentional. It sounds like there has to be someone thinking about it and making a design and a plan. When that's from the ecological science side, that's not included in the definition. And ecosystem engineering, when it was brought up, I don't think the word human or Homo sapiens appears anywhere in those papers at all. So it's a concept that originally came completely separate from any kind of social human relation. Then when you put it into humans and you apply humans to it, then it does sound like, you know, building things and agricultural land management and stuff like that. And that is, for us, that's our ecosystem engineering, and it does produce ecological inheritance. But the concept is actually very broad. And it's been argued that pretty much some people say, you know, are there some species that don't produce ecological inheritance? Are there some species that don't have any effect on the environment? And it's hard to come up with examples. So you could argue almost every species has some kind of ecosystem engineering. But then there's some species that really specialize in this. And we're probably the premier example. We pretty much can't live in environments we don't alter anymore. You know, just as soon as you start burning things, which people pretty much start to do right away everywhere, you start changing things more than a lot of other organisms do.
All right. Thank you. I think maybe there may be more comments or questions, but so it's 5 o'clock now. As well, the Clue Plus and Environmental Medicine Center and Effective Earth Life Science offer you a drink. So we have some drinks available. And let's first give Erle an applause again for the discussion. And you're invited to hang around a little bit or chat with Erle or ask the question you didn't dare to ask. He's quite approachable, I think. Are you?
I don't know. Depends on what you ask me. I'm not promising.
Outside we have more room for the drink than maybe here, so we can in the hall.
Thank you. Hope that worked out. Sorry for dropping your microphone. Looks like it didn't break.
This whole break proof.